So we'll be looking at developing carbon sequestration methods for our grand project. This is by Ahmed Yusuf, Jay Capel, Noah Oliver, and Mahad Mohammed. What is carbon sequestration? It's the capture of CO2, and it's the long-term storage of the carbon dioxide or other forms of carbon to delay global warming and avoid dangerous climate change. It's proposed as a way to slow the atmospheric and marine accumulation of greenhouse gases, which are released by burning fossil fuels. In general, carbon sequestration is taking carbon that we're producing from factories or other sources and either utilizing it in a different way or storing it. Why is carbon dioxide a problem? CO2's heat-trapping power has already started to boost average global temperatures. If carbon dioxide levels continue upward, further warming could have dire consequences such as rising sea levels, agricultural disruptions, stronger storms, which strike more often, and the disruption of ecosystems. So basically, as CO2 enters the atmosphere, it becomes trapped in obviously the atmosphere, and when sun rays then enter the atmosphere and hit Earth, they do not leave as they reflect off, but they don't leave as easily as they have before. They stay trapped within the Earth, and so this heat, so the CO2 keeps the heat in, and as this heat obviously generally increases, the icebergs and ice caps will slowly melt, and as icebergs melt, the sea levels will rise. As sea levels rise, coastline cities such as Miami and Tampa Bay, which are already pretty low, are in danger of being swallowed by the ocean entirely because of this rising water. And stronger storms, we've already seen examples of that with Hurricane Irma and Hurricane Harvey recently, which have been two extremely strong storms which have happened right next to each other in the same year in the same hurricane season, which is basically unheard of, and that's because of this increase in carbon dioxide. How do you capture CO2? You can replace smokestacks with absorption towers lined with chemicals that separate CO2 at coal-burning power plants. So this is attacking at the source and would be semi-effective. You can engineer artificial trees that have accelerated carbon capture capabilities. This would be interesting, but only if they also could produce oxygen. It depends on how useful just lines of plastic trees would be. And you can also burn coal or natural gas with pure oxygen instead of air. This eliminates the creation of carbon dioxide. Well, it doesn't eliminate it. It greatly reduces the creation of carbon dioxide. How do you store CO2? Logical places include old gas and oil fields. This offers many important economic advantages. The carbon dioxide interacts with the remaining oil to make it easier to remove. Injecting carbon dioxide, it dislodges oil trapped in the pores of underground rock, and carbon dioxide's presence reduces the friction impeding the flow of oil through the rocks to wells. So you can store these in the already open caverns in the oil and gas fields, which is there's less money spent on infrastructure there, and also, as you can see, it helps with the removal of oil. But an issue here is if there is, say, an earthquake or other issue in this area and the rock cracks and the carbon dioxide escapes, it could be potentially extremely dangerous for the environment. The three-step process to capture and store CO2. You capture the CO2 from the coal or natural gas-based power plant. You transport the stored carbon through pipelines usually. And then you store this carbon dioxide into deep, non-porous layers of rock that trap it and prevent it from migrating upward. And here is our works cited.